So vertical angles. Let's start with that one. Does anyone see something I should pull over into vertical angles? The which one?
Two angles.
The two angles that what?
40 and 40.
At 40? So that one?
Yeah.
Okay, those are vertical. How do we know that those are vertical?
Because there are two angles that are opposite of each other.
There are two angles that are opposite of each other when what?
When two lines intersect.
When two lines intersect. Does anyone see that description anywhere?
Yes.
Yes, where?
133 and X.
That is this one?
Yeah.
Okay. Is there any other car that can fit into this group?
133 and Z. Or X.
Yeah.
This one right here?
No, that one to the all the way to the left.
133 with the X.
To the,
This one right here?
Yeah.
Okay. Does anyone have any questions about that idea of those vertical angles there?
No.
Now I need y'all to pay attention to this. This is 40 and this is 40. So vertical angles have the same what?
Number.
Measure.
Measure.
We call it an angle measure. So here it's 133 and this is an X. So what is the measure of this angle down here? 133. We want to recognize those look like they're the same. They are the same. Same deal here. Vertical angles have the same angle measure. So let's look for adjacent angles. Can anyone give me show me adjacent angles?
That was all the way. The bottom right.
This is the bottom right here?
Yeah.
No, and now, I want to point this out because I heard some people debating about this one. All eyes up here. I heard some people talking about the fact that these angles right here would be complementary. But what does it mean to be complementary?
You gotta have what is it called?
Two angles
right
have a
angle.
sum of 90.
Oh.
Two angles have a sum of 90 degrees. First off, this big angle here, is that 90 degrees?
No.
No, that is not a right angle. Notice 32 is just this little piece, 58 is this whole thing. Okay? So am I supposed to add 32 and 58?
No. Yes.
58 is this whole thing.
No.
32 is just a piece of that.
You said
Does that make sense? Ooh, I heard someone say, can we subtract 32 from 58?
yeah.
And that would give us this angle. Okay, so what I want us to recognize, and we're going to talk more about this later, is called an angle addition postulate. Basically, if I add two adjacent angles together, it should give me the big angle. So 32 degrees plus, do we know what angle CAB is? Or CAD? Do we know it? No? So plus, does anyone remember yesterday how we would write, using symbols, the measure of an angle?
The squiggly line and the equal.
You think about congruent. Okay? Think about it. It's the measure of an angle. It starts with an M.
Then it has that little triangle thing.
Not triangle, it's just literally, it's called an angle symbol.
Angle symbol.
Okay? So the 32 degrees plus the measure of angle, how would I name this? CAD. When I add those two angles together, what do I get? Say it louder. 58. Hey, does that look familiar at all?
Yeah.
Have we studied anything like that?
Oh.
We learned how to solve equations last unit, right? This is one of the reasons why we learned how to solve equations, because what I want to do is find the measure of angle CAD. I know to add those two angles, I can get 58. What can I do to solve for the measure of angle CAD?
Subtract 58 minus 32.
Okay, why are you subtracting 32 from 58?
Never.
What do y'all think?
To find the angle.
Okay, but why would I subtract 32 from 58?
To get the difference to find out which leg that's missing?
Maybe, but look at this equation. Can I just subtract 32 on the right hand side?
You gotta subtract it on the other side of the equal side.
So on this side as well?
Yeah.
Why do I need to subtract it on this side as well?
So you create a 1 or a 0.
Well, okay, first off, I'm creating a what here?
0.
0. Why do I have to do it on both sides? To make it equivalent. This is an important idea. The reason why we did that review of equations to start is because it shows up even within geometry. we need to recognize that 32 degrees plus the measure of angle CAD is equal to 58. Well, I only want to know the measure of angle CAD. So what do I need to get rid of?
32.
32. So I got to subtract 32. Because I subtracted 32 here, got to do it over there. So I'm left with, what is 0 plus the measure of angle CAD?
The measure of angle CAD.
That's the point. So what is the measure of angle CAD?
What, 26?
26. That's it. Done. Any questions? Do we see how we can use the idea of adjacent angles to find unknown angle measures? Okay. Does anything else need to go with adjacent angles?
The one all the way to the bottom left.
This one?
Yeah.
Okay. Any descriptors that need to go with adjacent angles?
Two angles that share a common side and vertex.
And they do not overlap? Alright, so now let's look at complementary angles.
Two red ones.
The two red ones? Mari, how do we know the two red ones are complementary? You don't know? Okay, so Mari, you need to pay attention when we go over this. Terrence? If you add those two angles together, what do we get? 90 degrees. We go with that idea. Good with that? Amari? Okay. Does anyone see another complementary pair of angles?
The right angle.
Which one?
Top right.
Top right? Because what is 65 plus 25?
90.
90. So Matthew, are there any other cards that need to go with these three?
Oh, angles that have a sum of 90 degrees.
Ah, complementary angles have a sum of 90 degrees. That's complete. So now, all we have are supplementary angles, which, how do we know supplementary?
Angles that have a sum of 180 degrees.
They have a sum of 180. Please hear me very clearly on this. Because you have logged into this activity, if you ever log back into your account, you should be able to access this activity again. That can help you study for quizzes and tests. You literally just have to log into your account to do that. Okay? So let's look at number 4 though. So what type of angles are shown?
Vertical.
They're vertical angles. Anybody disagree with that? No? Cool. So Josh, what do you think the measure of angle B is?
43?
43? Does anybody want to disagree, or are we all in agreement on that?
Okay.
We all agree? Okay. London, why is this 43?
Because it's the same size, it's the same, but on opposite sides.
Okay. Notice how those angles are the same, just on opposite sides. We good with that detail? Yes? Oh, by the way, I meant to bring this up. My bad for not doing this earlier. If we look here at these supplementary angles again, does anyone know another name for these two angles?
No.
Obtuse.
One of them is obtuse.
Obtuse and cute.
Say it again. Okay, there's some rays involved, but look again at your notes.
A linear pair.
A linear pair. We need to recognize these are supplementary, correct?
Yes.
Do they create, are they adjacent and supplementary? Yes, so they are a linear pair. Notice the sides not in common create a what? Straight line. Well, all lines technically are straight, so just a line, yeah. Alright, number 5. What type of angles are shown? Be sure to select all that applies. Alicia, give me one type of angle that we see here. Say again. Say it louder. Vertical? Okay, so we may have, so where do you see vertical? Well, yeah, I guess there are vertical angles. Okay, so we can put vertical. Alright. Ireland, give me one more. By the way, let me say it this way. Felicia, where do you see vertical angles? You just call something?
Yeah, why?
Where do you see, okay? Hey, Terrence, don't be rude. You'd be so pissed off if someone else called you out like that, wouldn't you? Yeah?
No.
You're a liar. Alright.
I'm not lying, son. I'm not.
You must be right outside your mind.
I'm for real.
I'm also referencing the last word at the end of that sentence
Son?
that you need to remove from your vocabulary when respectfully talking to me. Jalen, do you see any vertical angles up here?
Yeah,
Where?
it's 29.
Right here? What other angle?
It's the other side.
So
The
here?
opposite side. The
No,
opposite side.
You almost there? Yeah.
There? So, Felicia, we do have vertical angles shown here, right? So if this is 29 right here, Austin, what is this one? 29.
Which makes.
Hey, Terrence, you talk. Let other people talk. I got 28 students in this classroom. All right, Terrence, give me one other type of angles you see. Okay, where do you see adjacent angles? That's not a description. What angles are you using? Do you know what I'm talking about? No. Use your words. This one? Are these adjacent angles? Sure. I don't know if I go as far as say linear pair, but what do we mean by adjacent angles? They share a common ray. Do they share a common ray?
Then answer the B.
Okay. Hold on. We ain't there yet. We ain't there. Hey, Terrence. You had a chance. Let other people share now. Come on now. Terrence. Did you volunteer and I got your answer? Did I respect you? Are you respecting the 27 other students in my class right now? Thank you. All right, Kyson, give me something else. Okay, where do you see complementary angles? Okay, so this right angle. So which two angles, though, are you saying are complementary? Can anyone help Kyson out to identify which two angles are complementary? Gabe? So Gabe, Kyson, notice the B and the 29 are what are giving me that right angle, right? You good with that idea? Okay, so we do have complementary as well. And so this is what Terrence was getting all bent out of shape about, but we weren't there yet. What is the measure of angle B?
90.
Just B is 90? How'd you get 61, Terrence? Huh? Because it has to equal 90. So what do we know about B and 29? They are being what?
Divided.
Added. And when you add those two together, you get
90.
So we need to get in the practice of this. Kelsey, what can I do to solve this equation now?
Subtract 29.
Because what's 29 minus 29?
0.
0. So I'm left with just B. But I got to make it an equivalent equation. So B is equal to 61.
Yep.
Man, we got almost everything. Does anyone see any supplementary angles?
Yes.
Where?
Oh, wait.
Where do you see it, Brooke?
Oh, I see. Never mind.
So here? And this one? So like here and here? Where? So show me. So where do you see supplementary angles? So you're going all the way across here. So that's what I was saying. Here and here. You're saying those are supplementary. Okay? Does anyone know how we should know that these two angles are supplementary?
They share.
There's a name for these two types of angles. Not linear angles. Linear pair. Because when it's a pair of angles, notice this pair of angles creates a what right here? A line. So that has to be 180 degrees. It's got all of them in there. And then we found the measure of angle B. And you can draw that on here. With B is 61. Alright. Kaylin, here on number 6, could you help us find the measure of angle 1?
All of them.
Kaylin, can you help us find the measure of angle 1? Or not? Claire, could you help us find the measure of angle 1? Terrence, where's the discussion happening right now? Terrence. Claire, can you help us find the measure of angle 1?
Add 1 plus 48 equals 78, and then subtract 48.
So the measure of angle 1 plus 48, you said, is equal to?
78.
What do y'all think about that statement? Do we agree with that? So these two angles added together would have to add up to the entire angle of 78?
Yeah.
Okay? That's a fantastic start, Claire. Jeremy, take it home for us. What are we going to do now to finish solving this, to find out the measure of angle 1?
Subtract 48 from both sides.
There we go. Because what is 48 minus 48?
0.
Making that a 0. So we'll have to measure of angle 1 is equal to 30. We good with that? All right. All right, I'm not sweating those. Okay, so here's what I want to look at now. If I can find it. Okay, so look on the back side of this naming angle sheet. We're going to do a couple of these together. The rest of these will be homework that is due on Friday.
Oh, yeah.
Huh?
Figuring out
You
now.
good?
I already picked it up.
What was that?
did?
Yeah.
Oh, it's my
Okay. So we should all have the naming angles sheet, looking on the back, looking at exploring angle pairs.
Oh, this is easy. 1 and 7 is vertical. 6 and 3 is vertical. 1 and 8 is vertical.
All right.
11 and 14.
I need everyone's eyes up here. Hey. So looking up here, and I want you to notice the directions. It says that angles 1 and 2 are supplementary angles. Then it gives us measure of angle 1 is 4x degrees, and measure of angle 2 is 8x degrees. Then find the measures of these angles. But it tells us more than just that. If you were just given that information, this would be a tougher question. What else does it tell us to do with these problems? What are the directions? How? Look at the directions. There are directions at the top of the page under exploring angle pairs.
Draw.
Draw a figure and answer the following problems. Draw them. So, if I'm looking at number 1, there's supplementary angles. What does that mean?
Add up to 180.
They add up to 180. So I'm going to draw a bigger angle. Maybe that's my angle 2. Why would this be angle 2 and not 1? Anyone know why that would be angle 2? Because we know angle 2 is what? Not necessarily obtuse, but we do know it is bigger. Does that make sense? So that's my 8x degrees here, okay? Then I have a second angle. It's smaller. And what is the measure of that angle? 4x. There we go. Now that you have it drawn, now that you know, hey, these are supplementary. Okay? Some people have already said it. Bashar, what am I going to do with that 8x and that 4x? I am going to put it in an equation. How am I going to put it in an equation, though? Bashar, what do we know about these two angles? It says it up here. They're supplementary. What does that mean, Bashar? They what? They don't equal 180. There's nothing
They add
to
up
say.
to.
They add up to 180. No, they're not the same thing. Because if you just say they equal, are you saying they multiply, they divide, add, subtract? Are they squared?
Is it
Right?
the same thing?
You need to be clear about this. If they're supplementary, you can add them. Thank you. 8x plus 4x is equal to 180. So how am I going to solve this?
Oh, I know how. Combine like terms.
Okay, so do we need to subtract 8x here?
No, we don't.
Combine like terms.
Yeah, notice we can add those two. What's 8x plus 4x?
12.
12x is equal to 180. 180 degrees. Now what would I do? We want to recognize. We're going to divide by what?
12.
No.
X is equal to? I don't know. Use a calculator.
15.
Is it 15?
I don't know what it says.
Oh, I didn't tell you not to get calculator. Sorry. Don't worry about it. It's 15.
Yeah, there you go. That time.
Okay? So we should then notice in number 2, angles 3 and 4 are what kind of angles? So what does that tell us to do?
Add.
That they would add up to 90. Okay, we're not going to do that one right now. Instead, number 3 is one you definitely need to draw. 2 lines intersect to form angles. If the 2 adjacent angles form are 4x degrees and 5x minus 27, I need to draw this. 2 lines. And which angles are we looking at? Adjacent. So like here and here?
Yeah.
Would those be adjacent angles?
Yes.
Yes.
Wait, no.
Those? Those would be adjacent? No?
No.
No.
Why not?
They don't share.
Okay, they don't share a common ray. What would these angles be?
Vertical.
Vertical. So where do I need to put that 5x minus 27? Over here on the side?
right there.
Okay, so we have adjacent angles now. What do we know about these 2 angles?
Oh, hey.
They add up to 180 because they are a what?
Complement.
They are supplementary because they are what type of angles?
A linear pair.
There we go. We know they're a linear pair.
Yeah, I found out. I'm really smart like this.
So they add up to be not 80,
What?
180, right? Linear pairs, they're supplementary, they add up to be 180.
Okay.
What would we do next? Do I like terms? 4x plus 5x? 9x? Now what?
Divide. No, I'm tripping. Add 27.
Add 27. What's negative 27 plus 27?
8 zeros. Cancel out.
So I want to point this out. Apparently a bunch of us know a little bit more about solving equations than we thought we did. I would be doing test corrections, coming to tutoring, and I might do a retest if I were you. Because y'all know way more than you give yourself credit for. Now what would I do?
Divide.
I'm not saying I'm
9. 9.
Because 9 divided by 9 is
1 or 8.
and so, well, it's 1, and then 1 times x is
8.
x. And then we would get 23. Now, I do want to point this out. Ooh, I did forget about this. Look at the directions again. Does it just tell us to find x? We know what x is for number 1. So, how would I figure out what this angle measure is? Substitute it in. 4 times 15 is 60. And then we do 8 times 15, which would be 120. You need to do a similar thing here. So, you already have most of it done. Continue to find those angles. Does that make sense?
Yeah.
We good there? Okay. This homework will be due on Friday, we'll go over one more of these, but the rest of this will be due on Friday. This will probably be the last homework, I think, that I assign before Friday. So make sure you take it seriously. Thursday you'll have time to ask some questions. Okay? Let's look, though, at number 7 together. How in the world are we going to find x and y?
Do one at a time.
Do one at a time. Do we see any relationships that we could use here?
Vertical.
Where do you see vertical angles?
Right there.
Wait, which one?
7y plus 5.
7y plus 5 is vertical to.
9x plus 2.
That means they're gonna be the same answer.
So that means that 7y plus 5 and 9x plus 2 are what?
Equivalent.
Vertical.
Equal.
Those measures, remember those are angle measures, are equal. But we have two variables there. I don't want that. Does anyone see any other relationships we could use?
25, 8 plus 8, and that's vertical too, so they're gonna be the same answer.
Vertical to what?
They're gonna be right there.
Whatever
Yeah.
that
Do we
is.
know what this is?
No, that's why you gotta find out.
Does anyone see another angle relationship we might be able to use?
25x and 9x.
Okay, these are adjacent, but there's something else with those two.
Combine the
Linear pair.
yeah, like term.
They're adjacent and they are supplementary, so they are a,
Linear pair.
Linear pair?
I just said it.
so, I know, but not everyone else was there. So these are a linear pair, so what can we do with them?
Subtract.
So they,
Merge. Complement. I don't know, merge. Intersect.
they,
Intersect.
what's a mathematical way to say
Intersect,
they,
man.
no, they don't intersect, man. Okay, what's a mathematical word to say they combine? Thank you. So they add up to what? They're a linear pair. What do they add up to? 180. They're supplementary. So 25x plus 8 plus 9x plus 2 is equal to what? 180. This is why we would spend time learning how to solve equations again. This is one of the things that we do in geometry. It is a little bit harder, but what do I need to do to get started?
Combine like
Combine like terms. Like what? Which ones are...
25x and 9x.
25, 8, 9.
Now, one thing I will point out, if you want, because this might make things easier, is I might use what property right here? The commutative.
30, 40.
Because notice, that makes it a little bit easier to add. 25x plus 9x is 34x plus 10 is equal to 180. Now what can I do?
Subtract.
Subtract how much?
10,
Because what's 10 minus 10?
0,
10 minus 10 is 0. So I'm left with 34x is equal to 170.
and then you divide it, 34. 34.
So x is equal to 5 degrees. That's it. X is equal to 5 degrees.
Thank you, buddy.
5 times 30 is 150. 5 times 4 is 20. So 150 plus 20 is 170.
The living calculator.
You can also just think about, well, yeah, that's what I did. Yeah. Okay. So if we have x is 5 degrees, how can I use that to help me figure out what y is?
It's gonna be the same thing.
Excuse me?
Somebody?
It's gonna equal.
You said what?
It's gonna equal 180.
It's not necessarily going to equal 180. If I know that x is 5 degrees,
Yeah,
how can I help that use that to help me solve for y?
divide.
7 times 5.
7 times what?
7 divided by 5.
No.
What is 5 degrees?
Yeah,
X.
so times 5.
So where can 5 go?
Beside 8.
Can it be substituted in for x? Not for 9x, just for, just x is 5 degrees.
And then 45.
7y plus 5
45.
is equal to 9 times 5 plus 2.
7y, 5 equals 45.
Slow down.
What something?
7y plus 5 is equal to 47. Now what?
Then minus 5, it is 42,
So 7y is equal to 42.
divided by 7 is y, and them difference 12 is 6.
So y is equal to 6 degrees.
Yeah.
Okay?
I did all that math in my head.
Send it back here.
At least I'm getting.
I agree that you are very intelligent, but what I need you to do is to focus on your hard work instead of your intelligence. This is why you give up on yourself, because all you care about is whether you're smart or whether you're dumb. That's not what it is. How hard are you working to learn? You were fully capable last unit. You didn't give yourself a shot. Okay, so the rest of that is due on Friday. I'll give you a chance to ask questions on Thursday. Alright, for the sake of time, because we need to get to slope, we're going to move through this next little piece quickly. While you finish taking notes, I'm going to pass something out. What? No. She got to class on time. Yep, we're going to get to slope it by the end of class today. What else said? Slope.
Oh, it's slow.
Alright. So, please hear me very clearly on this. What I just passed out is to help you see and understand some key ideas, which it helps when we have our heads up. Anton, Kaylin, or continue to sleep, that's cool too. Alright, so what I need you to do is I need you to go to this website, it's on your sheets, okay? And I'm going to walk you through a couple of things to help you define some ideas. Geometry.org/geometry. Okay? This is what you should be looking at right now. There's a sheet like, or a screen like this. It's on the sheet in front of you that I just passed out. Yep. Go to the link on the sheet, type in the URL. Huh? Get what? Okay, quickly, but I need you to get to GeoGebra. Alright. Say again.
What is GeoGebra?
What do you mean like this? It should look like this. Alright. No, it says it on the sheet I passed out,
Right here?
exactly what the URL is.
Right here?
Right here.